Hi everyone. I was able to spend the last 2 weeks preparing the rock off the surface of the bone, and the plan had been that this week we would talk about gluing the fossils together. And in some cases, such as right here, these two bones actually fit together really nicely. But that's not always the case. I discovered that in a lot of areas, the bones did not fit, and it's largely because inside the fractures, there are a lot of gypsum crystals that had grown. And they filled in the space where we would like to have two broken pieces of bones articulate together cleanly. Now I'm going to have to actually sit down and prepare away all of that gypsum from the inside of the fractures, but I think this is a great time to stop and talk about taphonomy. Taphonomy is the study of what happens to an organism after it dies, whether it's the disarticulation of the skeleton or damage caused by a predator, all the way through to the burial of the specimen and changes that occur to the bone after burial and when it's becoming fossilized. Now there are a lot of things that happen to this specimen. We know that the Otis chalk bones are disarticulated and they're buried in a mudstone matrix. And then they were coated with some ironstone, and we have gypsum crystals that grew, plus slicken slides or slicken lines on the surface of the ironstone. Now, to tell the story of what order in which all of these different things happen to the bones, we need to look at the principle of cross-cutting relationships. To help explain the principle of cross-cutting relationships, I've created a simplified geologic cross-section. Each colored band indicates a sedimentary rock unit. The oldest units are always on the bottom, and each subsequent layer is a slightly younger and younger layer of sediment that was deposited over top the previous layer. You can see that there is a dark black line right here, and that the layers don't match up across that line. This line is actually a fault, and at some point this rock unit was compressed, and the units on the left side were actually pushed up slightly over top of the units that were on the right. Now this fault line goes up until it's cut by a more recent squiggly line. This is actually an unconformity. Unconformities are gaps in time. This actually represents a time where the rock units were eroded. So actually, there may have been some units that were higher than this brown one, but they were weathered off the surface. And afterward, more sediment was deposited over the top, burying this fault line in unconformity. Now, when we take a closer look at what happened to these Otis chalk fossils, first of all, the animal died and something happened to disarticulate the specimen. We don't know if there's a predator scavenging the carcass and separating the bones apart. At this point, we have not found any clear bite marks. After the skeleton was disarticulated, it was sitting in a quiet body of water. If this animal had been sitting in a fast-moving stream, it would have been deposited within a body of sandstone. But instead, it sat in a nice still body of water where the mud was actually able to precipitate out of the water column. Here we have actually the water that I used for scrubbing the specimen, and you can kind of see that over the past 2 weeks, the mud has mostly settled down to the bottom. And you can imagine that this is what happens in a pond where the sediment is slowly settling down and covering up the bone. The next two steps that probably happened to this specimen are the bone being fractured and the precipitation of the ironstone concretion over the surface. Now, what we can see when we prepare this specimen is that the ironstone does not actually coat the inside of the fractures. So what likely happened is that the ironstone grew around the surface of the bone, and then afterward, the bone was fractured. probably the fracturing was caused by the compression of overlying sediments smashing down the mudstone and thus fracturing the bone. When we look inside of the fractures, we do see that there are gypsum crystals that have grown inside. And they're mostly found inside the fractures, and they're less common on the outside of the bone. So probably this happened after the bone was fractured. Now, the last alteration that happened to these bones is probably the development of the slicken lines. You'll recall that the slicken lines are created when the bone is actually being moved within the clay, and the clay polishes the surface of the ironstone. This probably happened a little bit more recently than a lot of the other modifications that happened to these bones. In fact, it probably happened after erosion exposed these bones close to the surface, and the clays of the Otis chalk were able to shrink and swell, thus moving the bones within the sediment. During the next week, I'm going to go through and prepare off all the gypsum from the inside of the fractured surfaces. That way, I can go ahead and glue the bones back together for you.